Welcome to homework set number 3 for ECE 341. In this homework set, we look at calculating the odds of a dice game called Yahtzee using combinatorics and introduction to Z-transforms. The first problem looks at the game of Yahtzee. With Yahtzee, you roll 5 dice. What's the probability of rolling a full house with one roll? That would be 3 dice of the same and 2 others that match. Well, to calculate that would be there are 6 dice values, pick 1 for x. Of the 5 spots available, pick 3 of the 5 for where to put x. There are 5 remaining die values, pick 1 of them for y, and of the 2 remaining spaces, pick 2 for where to put those 2 y's. Multiply it all out, I get 300. So there's 300 different ways to get a y, or to get a full house. The probability of getting full house is that divided by the total permutations for how to roll 6 dice, gives you 0.00643. Problem 2 is repeat for 4 of a kind. With 4 of a kind, I have 4 x's and a y. To calculate that using permutations, there are 6 dice, pick 1 for x, 5 different spots, pick 4 of those spots for where to put the x's. There's 5 remaining values, pick 1 for y, 1 remaining spot, pick that spot to put y. Multiply it all out, there's 150 different ways of rolling 4 of a kind, with a probability of 0.003215. Problem 3 looks at probability of getting 3 of a kind. So here I have to have 3 dice that match and 2 dice that are different. So to get there, there'd be 6 numbers, choose 1 for x, 5 different spots, choose 3 of those spots for where to put x. Now for y and z, there are 5 remaining numbers, pick 2, and then y can go in 2 spots, choose 1. Gives you 1200. Another way to do that also works, is there are 5 remaining values, pick 1 for y. There are 4 remaining values, not x and y, pick that for z. That also gives you 1200. Either way works. Giving a probability of 0.025 of getting 3 of a kind. Now I can check my answers. Using MATLAB, go through enumeration to calculate or determine the actual number of ways of getting 4 of a kind, 3 of a kind, and a full house. So here what I do is I go through every permutation. So I'm going to roll 5 6-sided dice. Here's every combination of 5 6-sided dice. And then count the frequency of each number. If the most frequent number is 4, I've got 4 of a kind. If the most frequency is 3, then a 2, I've got a full house. If it's 3, I've got 3 of a kind. Running through every permutation, I wind up with 150 4 of a kinds, 300 full houses, 1200 3 of a kinds, which matches up with my calculations. Problem 5 looks at a z-transform. If this is x of z, find x of k. To do that, I pull out one of the z's. I'll need that later on when I take the inverse z-transform. Now do a partial fraction expansion. To get the first term, I cover up the 0.98, evaluate at z equals 0.98, and I get 6.125. Next, to find the second term, I cover up the 0.96, evaluate at z is 0.96, and I get -8. Finally, to get the last term, I evaluate at z is 0.9, cover up this term, evaluate the remainder, I get 1.875. So here's the partial fraction expansion. Multiply through by z, and now take the inverse z-transform. So this is 6.125 times 0.98 to the k, -8 times 0.96 to the k, plus 1.875 times 0.9 to the k, for k positive. Problem 6 is similar. In this case, I don't have a z in the numerator, so what I do is I multiply both sides by z. Now do the partial fraction expansion. For the first term, cover up the 1, evaluate at z equals 1, I get 1. Next, evaluate at 0.95, cover up this term, and I get minus 0.667. Finally, to get the last term, I cover up the z minus 0.8. Evaluate at z equals 0.8, I get minus 0.333. Multiply through by z, take the inverse z transform. There's your 1 minus 0.667 times 0.95 to the k, minus 0.333, 0.8 to the k. That's zx. Divide by z. Whenever z means delay, so take all the k's and replace them with k minus 1, a delay of 1. So here's your answer. There are other ways to write it. What I could do is also write this as 0.95 to the k and pull out the 0.95 to the minus 1. So that would be your 0.6667 over 0.95 to the minus 1. And likewise over here, either answer is valid. Finally, if I want to buy a Ford F-150 Lightning for $72,000 on Cars.com, take out a 60-month loan at 4.74% interest, what's my monthly payment? That's actually Z-transform. The way I would write that is the loan amount next month is the loan amount this month times 1 plus A, where A is the interest rate, plus the loan amount times delta of K. I borrow $72,000 at K equals 0, plus my monthly payment. And I don't pay during month 1, month 0, I start paying at month 1. So this is a unit step starting at K equals 1. Take the Z transform. The future value is Zx. X is just X. Delta is 1. And a unit step is Z over Z minus 1. Delayed by 1 gives you 1 over 1 minus Z. Now bring all the x's left. Solve for x. Do a partial fraction expansion for this term. Take the inverse Z transform. And again, I don't have any z's in the numerator. I want those. So multiply both sides by z. That puts this in the form that's in my table. So this is 1 plus a to the k times my loan amount plus, pulling out a p over a times minus 1 plus 1 times 1 plus a to the k. Delay everything by 1, divide by z, and I have x of k is all this delayed by 1. So here's the general equation for how much you owe at month k. If my loan is for 60 payments, then at x of 60, my loan amount should be 0. Plugging in numbers, I can sit there and find the monthly payment. So plugging in numbers, I wind up with $1,376.4. If I buy a Ford F-150 Lightning, my monthly payments are going to be $1,376, and you got yourself a Lightning. So that's actually Z-transform. And that is homework set number 3 for ECE 341. The next homework set will actually look at using Z-transforms for calculating probabilities.